Good day to everyone. In this video, we will discuss how to obtain the inverse of a matrix making use of row operations. So to start off the discussion, suppose we have a matrix A having elements 2, 0, minus 1, minus 3, 1, 1, and 1, minus 2, 3. Now, this early, we can say that the matrix A will actually have an inverse because its determinant is equal to 5, and because the value of the determinant is non-zero, then by theorem we know that uh, the inverse of the matrix A will exist. And that being said, we can now start the process of obtaining the inverse making use of row operations. So the first step is to construct an augmented matrix where the left-hand side corresponds to the matrix A. So let's write that augmented matrix down. And the right side of the augmented matrix will correspond to the 3 by 3 identity matrix. And the objective is to be able to transform this augmented matrix into a matrix of the form where the left side will correspond to the identity matrix, while uh, the right side of the final augmented matrix will be a non-zero 3 by 3 matrix, which will actually coincide to the inverse of our given matrix A. And so the our tools in transforming this matrix into this matrix is exactly the row operations which will apply to our matrix. So the first row operation that we will do is to interchange rows 1 and 3. And so what will happen is we will get a new augmented matrix where the first row and the last row are interchanged. However, the second row will still be the same, and we obtain now our new augmented matrix. Now, we focus on the first row where the first non-zero element is already equal to 1. So this is good because our final objective is to arrive at an identity matrix on the left hand side of the augmented matrix. And so the value of this being equal to 1 actually facilitates much more easily the transformation that they will have to carry out on this matrix. And so this becomes our pivot element. So this is our pivot element. And the objective then is to make the other elements in that column, namely minus 3 and 2, both equal to 0. And we do that by the following step, or the following operations. So I have a new row 1, which I will call R1 tilde, and I can multiply this new row 1 by 3 and then add it to row 2. And also, I can multiply uh, the first row, which is this R1 tilde, by minus 2, and then add it to row 3. Now, this operation then goes as follows. So we have 3 minus 6, 9, and then we have 0, 0, 3, and then add that to minus 3, 1, 1, 0, 1, 0. So we will get 3 plus minus 3 is 0. This is minus 5. This is 10. And then this is 0, 1, 3. So we still have the first row for our new augmented matrix. So 1, minus 2, 3, 0, 0, 1. However, our second row we replace by this row. So this becomes 0, minus 5. So let me write this more clearly. So 0, minus 5, 10. And then 0, 1, and 3. Now, if we carry out this operation, minus 2, R1 tilde. So again, let me write this out more clearly. So this is R1 tilde, okay? If we multiply the first row, R1 tilde, by minus 2 and add it to R3, what we will get is the following row. So 0, 4, minus 7, and then 1, 0, minus 2. So I will leave it up to you to verify the fact that indeed, if we multiply this row by minus 2 and add it to this row, R3, then what we will get is exactly this row. 0, 4, minus 7, 1, 0, minus 2. And that said, we now focus on the next step of the process. But if you will notice, if you go back to the first row, the first non-zero element is 1. And notice that because this is our pivot, you will observe that the other elements in this column are already 0. And so now we focus on the next row in our augmented matrix and focus on the first non-zero element, which is minus 5. So now this becomes our pivot, and our first task is to make this element, the non-zero element, become a 1. And so to that end, I multiply this row by negative 1/5. Okay. If I multiply the second row by negative 1/5, we will get 0, 1, minus 2, 0, minus 1/5, and minus 3/5. Okay. And our objective then is to turn the other elements in that column equal to 0. So the minus 2 would have to be transformed into a 0, and 4 here would also have to be transformed into a 0. So to be able to do that, I specify the operations I will have to carry out. So my new second row, which is this, is R2 tilde. So I can multiply R2 tilde by 2 and add that to R1. And also multiply R2 tilde by minus 4 and add that to R3. So 2R2 tilde will be 0, 2, minus 4, and then 0, minus 2/5, minus 6/5. Okay. And then I add that to the first row here, which is 1, minus 2, 3, 0, 0, 1, which will give us 1, 0, minus 1, 0, minus 2/5, minus 1/5. And so I replace the first row before with 1, 0, minus 1, 0, minus 2/5, and then minus 1/5. Okay, and so what about the third row? So for the third row, if we carry out this operation, then what we will arrive at is the following row. So I will just leave the calculation up to you, the viewer. So this will become 0, 0, 1, 1, 4 fifths, and 2 fifths. All right, so we are actually getting close to obtaining an identity matrix on the left side of our augmented matrix. And so we now focus on the next step, okay? But just as a review, notice that the pivot element in this second row is now equal to 1, while the other elements in that column are all equal to 0. And so that is the signal that we now proceed to our final row, which is the bottom row, and the first non-zero element is already equal to 1. So what we will do is, let's try to construct our last augmented matrix. And um, this element here, being the pivot element, would tell us that we have to turn this element, the -1 and the -2, both equal to 0. So to do that, so I will denote my third row now by R3 tilde, and I can multiply this row by 2 and add it to row 2. And furthermore, I can multiply this third row by 1 and then add it to row 1, so that all of the other elements in that column will become 0. And so if you carry out this operation, then what will happen is the second row will get replaced by the following. So it will be 0, 1, 0, 2, 7 fifths, and 1 fifth. While if we carry out this operation, 1 times R3 tilde plus R1, then what we get is 1, 0, 0, and then 1, and then here we get 2 fifths, and then we have a 1 fifth. So if you will notice, the left side of our final augmented matrix already corresponds to a 3 by 3 identity matrix, I3, and the square matrix that we have on the right side, which is this, will now signify exactly what the inverse of the matrix A will be. So A inverse will now be equal to 1, 2 fifths, 1 fifth, 2, 7 fifths, 1 fifth, 1, 4 fifths, and 2 fifths. And this is the inverse of our given matrix.